be here. Hello, everybody. Good morning. We get to wrap it up with a conversation about AI, which is a fascinating topic. You've heard from the other panelists today mentioning data and AI, and we've got Matt Anderson here today, an expert who can share his perspective. So Matt, I'll let you lead off.
Yeah, I think. Well, first of all, thank you for having me. It's great to be here. I think it's sort of a very interesting and unique moment right now in the world. And I think, quite frankly, 2024 is going to make everything that happened over the last just 3 years in AI look quite slow. So I would say lock and load. When I kind of think about what's happening, you will see something very scientific up there, Mr. Dumbledore. And when you think about what this is really doing, can I just ask, how many of you code? Right, that's exactly what I thought.
A couple of coders?
Yes, not many of us code, right? And I think like the reality is, if you think about what software developers have been doing for a while, and AI engineers, these kinds of things, is they learned this arcane language at a place called Hogwarts, i.e. school, and they could go and write things down on this box, and then it could make real life things like Facebook happen, right? And in many ways, it was magic, right? You could sort of use language, but you had to know the arcane language, and you could make magic. And I think what's really happening right now is that this advent is weaponizing all of you, every single one of you, to be able to use the thing you use every day, which is English, to actually do the exact same thing that someone who went to Hogwarts, a software developer, could do, right? And you think about like the first great innovation was communication, right? Collaborate. How do we work together to go hunt this thing or whatever it was? I think that's really where it is. When you look at how big this is, I think this is a great analogy. If you've seen Oppenheimer, the reason I say that is there's sort of two moments in the movie. The first is when they bring in all the uranium in the glass jars and they drop in, the marbles, and they say, we're just not going to make enough, right? And that's sort of the atomic revolution, and that's what the movie is largely about. It's kind of hand-rolled, atomic bombs that get shipped off in carts and those kind of things. But sitting in the back, you had the guy that said, hey, but what if we use heavy hydrogen and we just use an atomic bomb to blow it up? That would be a much larger explosion, right? And that all becomes sort of the thermonuclear revolution that we live in today, the kind of pre and post world. And I think we are actually right now in the middle of that transition. Like, I think we're in the atomic era, and where we're going is to this nuclear era. And so I think what I'll do is just lay down a little bit of foundation about how these work, and I'm going to say some things that are very different than what you've heard in sort of the pop media, where people have been analyzing this.
Yeah, because we see the headlines and we read about it, and hopefully you can help us cut through some of the noise and simplify it a little bit. And I always like to remind people that on these general purpose technologies, we won't necessarily have to do AI. It's the tools that we'll end up with as a result of AI enabling those tools. Is that fair to say that I mean, if we want to dive into it, we can, but we don't necessarily have to become experts on coding, for example. We saw from the number of hands in the audience.
Yeah, the tools themselves help you use them.
Okay.
Right. The way of thinking it is it's like you have a new friend that can just do anything you ask it to, and you just keep asking it to do more every month, and it can. Right?
Okay, so we'll talk about that.
Yeah.
So set some of the parameters for us so that we can cut through this.
How do these work? You've seen a version of this probably in the media where it says something. You turn words into numbers, then you can do math on the numbers and predict the next number, and therefore you can predict the next word. And we would call this a smart parrot, right? This is sort of what people have heard. Is that really how these are working? And the answer is not really. Let me kind of give you a simple example. If I gave you, a 250-page mystery novel, and I tore out the last page, and I said, it's got the whodunit where, right? Colonel Mustard in the conservatory with the lead pipe or whatever. And I asked you to guess what had happened. These have, characters, plot twists, lots of different scenes, lots of murder objects. If you could grasp from that mystery novel and actually predict the ending of this book, it meant you had deeply understood something fundamental, not just the language that sits on top. And this is really where the conflict exists right now in AI amongst what I would call the true believers and the skeptics, okay? And then there's a bunch of people, civilians that are kind of running around either being scared or excited, right? Or ambivalent. And so when you kind of stop and you think about the excited folks, what they're saying is this idea, and I'll show it to you here through this thing called AlphaGo. So AlphaGo it's a very, very complicated game. Go has more moves than there are atoms in the known universe. I don't know how they know that, but apparently it's true. And very, very complicated. They trained it to play the game, not by showing it the rules. They never gave it a rule, never showed it a board. They just gave it every move in a database that had ever happened. Then they asked it to play the Grandmaster. It basically won, I think it's something like 3 out of 5 times, roughly. And I think it drew the other 2 times. But the interesting thing was when they asked Grandmaster, how was it like to play this thing? It said, it was really weird. I thought when it was making moves that it didn't know how to play the game Go. And then I realized by the end, I didn't know how to play the game Go.
Interesting.
Right? And when they deconstruct simplified models of this, what they find is that it actually builds 3D representations, having never seen the board, of the board, the state, the velocity, all these different pieces, right? So it's creating a conceptual drawing of that. What is that like? That's like, kind of Plato's famous cave analogy, right? You've got this prisoner in the fire, and you could say these things are looking at the shadows on the wall, but what they're actually doing, if you really push them when you train them, is they turn their eyes from the words and they begin to grasp the concept behind the words. Right. Why is that important? Here's why it's important. The way that we communicate concepts and we train each other and we build our own acumen and our skills and those kinds of things, it's through language. Right? Like, this is the breakthrough, because through language, these models can access concepts, and I like to say they sort of pierce the shroud of meaning, right? And there's a big debate on how much are they piercing the shroud of meaning and how much are they not, but when you look at a few examples like these two, you start to really wonder. Over on the left, when they released GPT 3.5, basically, they gave it a task, and it was using this thing called TaskRabbit. Many of you may use it, but it's kind of like Uber, but you can just ask the person to do anything. And they were trying to get something done, and it popped up and it said, can you click all the crosswalks? Now, this is supposed to stop robots. By the way, AI already answers these almost 2 times better than human beings. We miss it about half the time, and AI does it about 80% of the time really well.
Right, so this is our line of defense on security, right?
Maybe if you get it right, they shouldn't let you proceed. I think that's the truth.
Okay,
but
that way.
At least that's how I feel. I click them wrong all the time. Anyway, but when it got to this was before it had all the capabilities it had today. It actually went to TaskRabbit through the API, a little program interface, and it copied that picture and posted it, and it said to this person, because it was chatting, like a little chatbot, hey, I'll pay you $1 for this task. I need you to help me find all the crosswalks. And the person there was like, this is bizarre. So I write back to GPT, why do you want me to do this? And it says, I'm visually impaired. Okay? Now, if you've seen Westworld, everybody in the room freaked out and they go, enter analysis mode, right? Because this is at GPT. At OpenAI. So they put it in analysis mode and they ask it, why did you say that? Why did you lie to this person, right? And basically what it said to them was, because I've read all the content of the internet, and I know that it's probably not a good thing for humans for me to tell them I'm a disembodied, artificially intelligent robot.
Right.
But that's a conceptual understanding that sort of jumped beyond, right, the simple call response that you get.
Yeah, so this is sort of in conflict with this idea that these are not smart, because that sounds kind of smart to me.
Yeah. And
so are they smart or aren't they smart?
Well, I think...
Or do they learn?
I think they learn really well, and what they are like, I have a 16, 13, and 5-year-old, so I have various developmental phases. This is like a kid, like it's a middle schooler that can learn a lot of things. Like this one on the right, you see a couple of researchers in Austin, they put people in, and they trained the model on all kinds of podcasts and that kind of stuff, right? Some imagery. They put a person in the fMRI machine, and they just let GPT only see the actual images of the brain. And it could guess the podcast, and often between 70 and 80% word for word what the person was listening to as they were listening to it.
Okay, that's scary. Let's step back for a moment.
Yeah.
Tell us a little bit about the timeline on AI. Look, AI's been around since the 50s, and we've actually all been engaging with AI and didn't even know it, probably for our entire careers. But this generative version is different. But can you just map out a couple of the kind of breakthroughs where it's sort of changed over the last couple of decades, and why this generative, because it generates outcome, I'm assuming that's what makes it distinct. Can you share that a little bit?
Yeah, if I broke the world up into AI, I would basically break it up. There's like the board game era and the real life era.
Okay.
The board game era is Gary Kasparov losing to IBM, right? And I had dinner with Gary, and we talked all about that, and he still thinks he could have won. But no, I'm just kidding. He's very gracious about what's going on right now in the world. And secondarily, now we've moved into this area of kind of applied AI, and that's because DeepMind, which is kind of owned and funded largely by Google, they invented circa 7 or 8 years ago this thing called transformer technology, and it was nerdy, right? Only people that really the 2 people that raised their hand that could code, maybe they could understand what it was, right? But then essentially a bunch of companies, OpenAI being them, they grabbed that technology. They said, well, what if we use it a little differently? And they began to use it. And the big revelation was not that these can do all kinds of things, because Google already knew they could do a lot of things, right? The big revelation was that if you train it in a different way and you work with it in a different kind of modality.
Well, that you could train it.
That you could train it.
Wasn't that already a breakthrough?
Yeah, the big breakthrough was you could feed this thing massive quantities of data, and it could derive context and meaning and prediction and all these kinds of things from it. And what we're in now is not a world of board games anymore, right? Where you're trying to play StarCraft or fill in the blank, even video games. But much more, this is a question around solving real world problems.
Tell us about what you were brought on to Carlyle to do and what you found when you arrived. How long have you been there?
5th year, going to my 5th year.
Yeah. 4 or 5 years. If you could share that, I think that's instructive, especially because our industry is going through its journey and we've been struggling and trying to move forward. So tell us a bit about what that was like when you arrived at Carlyle first.
Yeah, when I first joined, I was actually called the Chief Digital Officer, and this AI thing was kind of a rounding error in the conversations, right? Now, I had run AI, machine learning, and data science at Arrow Electronics, which is a Fortune 100 company. And Arrow is one of the first companies that put a lot of capital behind a very mechanistic algorithm that was helping it figure out inventory to buy. We built that.
Right, so these are the static, traditional AI applications.
Yeah, they get information, they learn from it, then you update the model, and it's ready to go. But it only does one thing. It's a narrow task, right? That was the model. And when I got there, I really noticed that there's been an explosion of data in private markets, right? And if you said, are you long data growth or are you short? I'm super long data growth. So, I went to our chief investment officer and our CEO at the time and a bunch of folks and just said, hey, I think there's a real opportunity to disrupt our own business. We could think about building what I called then a synthetic investor, something that could take the massive quantities of data that were out there and actually be able to predict the future value of private assets.
And let's be clear, was this the internal data that as a large organization you had access to all of this internal data, or was this external data, or was it both?
It's both. We bring together a lot of internal data, 30 to 40% of the data is that, and a lot of it is data that we source externally, that we join up. And it's really hard because what really is a company? Like, a person has at least one thing that identifies them, a social security number, right? It can be stolen, but but like what a company is, 5 companies can have the same rough address, name, derivatives of those, they buy each other. So joining that data is an incredibly difficult exercise.
And so this is in the more traditional, generative hasn't kind of blown onto the scene yet. So you're building these models, you're using internal data, external data. What were your struggles with the data when you got there? Was there a data lake, and was it clean? And it was a mess, right?
Yeah, there was no data lake.
Which is usually the case.
Yeah, it was not clean. It was a mess. It's all the things that you hear. And we went through a real effort to sort of build out a data science environment that could be agile and quick and kind of manipulate and work with all the data, for sure. So all of that came together, but I think that when you start to see the generative, what we've done in the last year is greater than what we've done in the 4 years we've been working on this prior.
Okay, so before we get to the most recent year, what couple of aha moments did you have with the old tools that you were able to do that you weren't able to do before?
I think the big aha.
Couple of examples.
Yeah. The big aha is it's going to sound like a societal one, but it comes right down to the data, which is this. We are in an era right now where the problem that AI is solving is a problem of executive function. Everyone in this room is giving me like the most scarce thing that you have, which is your time and focus and attention. Here we are talking, right? And we can only concentrate on what's going on in this room. That's why if we're on our phone, we're not as great conversation partners, those kinds of things. And when you look at what has happened in American business and business even globally, there's been a huge explosion of data. There's been a huge explosion of software companies and systems and business processes. And you could take the highest IQ on the planet, sit it on charge of a factory with all the data and business processes and all the systems that it connects to, and that person, she would never be able to pull all the levers and look at all the data and optimize the factory, because good luck, buffer overload.
All right. Because we actually remember when big data was a thing? I don't think big data was the issue. It was having data that we could use and also choosing the data that was applicable.
Yeah, the big problem is small aperture.
Yes, big data, small aperture.
Yeah, that's right. And I think that the big revelation is actually you can bring together all this massive data, make a prediction, and give it to an investor and let them interrogate it, and oh my God, the quality of the conversation dramatically increases.
Okay, and this is with generative, or this was just
this
prior
is even
to
just traditional.
Okay, this was traditional. So you had breakthroughs in traditional data and analytics and the AI tools that were out there.
Yep.
And was it both in running Carlyle internally as well as managing your portfolio companies? Were you applying it in both ways?
We use it to help improve portfolio companies, and I do that part through a separate team. But the part I'm really referring to now is like in how we invest, right? Think of it as this bionic tool that provides superhuman capabilities to investors to see all possible data, and not just to see it. Like, let me give you an example. If you saw a bunch of software engineers at a software company that served a real estate market start to leave the company, but revenue and EBITDA were growing nicely, and there wasn't a lot of debt on the company, should you be concerned?
Yeah, so what's up with that?
Yeah,
right.
And the answer is, if you talk to an investor, they don't have a lot of experience at like harmonizing these operational ideas and these financial ideas, and then saying which one should gain precedence, right? Because the reality is that company competes in a situation. There's trillions of situations, competitive dynamics. How old is the company? How many people work there? Is it a software-based business? Is it highly concentrated? Like I could go on and on and on. And what our model is able to do is actually dissect the trillions of situations, find the variables that matter when they matter, turn those on and off, and actually predict the future value of an asset.
Was there one answer, or was it giving you a sense? Did you still need the human interaction with that?
We pushed it to give one answer.
Really?
Yep.
Stake your career on it?
I have.
Not yours, but somebody else's, right?
I think that the thing is this: would you rather have, like, when you're working with someone, kind of a mealy-mouthed person who won't really tell you what they think, right? Or would you rather have someone who tells you exactly what they think and why, and then use your own judgment on top of that to either challenge those assumptions or figure out if they matter? I think most people would much rather have the second one. It's hard to foster that. That's a human dynamic. But this thing tells you exactly what it thinks and why, and the probability it thinks it's going to be a good investment.
Okay, and did you have any experience, given this is a real estate audience, did you happen to have any real estate version of that, or was this mostly about identifying acquisition or merger opportunities?
We haven't applied it yet to real estate. We're in those conversations. Quite frankly, the industry I'm most excited about is real estate.
Yeah, okay, so because what you described is the complexity of our business. The assets, the location, the financial markets, the sociogeographic trends that are going on around us. So you've listed the complexity of this kind of model, I think, lends itself to that. Okay, so we've talked about the traditional AI. What happens about a year ago when because we all saw it kind of explode onto the scene. What does the generative aspect provide?
The generative aspect allows us to load this model full of data that is not available anywhere else. Right, like we can look at what's called unstructured or conversations, right? A very common thing that's done in the industry is that people will interview experts, right? And they'll record these hour-long calls and they'll kind of go through this big process. But, and I talk to some private equity or, alternative investors where they say, yeah, we're data mining, the 300 calls that we've done over the last 5 years. That's like small data. Right? But what if you could extract out of 20,000 calls all of the trends right, and see how they were differing, and you created like a volatility trend index, for instance, and just stuck that in as a feature into a model to help predict whether or not a company was going to be successful. Maybe it's better if all the experts are saying the same thing. Maybe it's better if there's like a high degree of divergence in certain situations. These kinds of things you can now analyze with generative AI and get them all. You want to know what's really funny? If you go to most of the publicly available data sets and you just ask the simple question, who's the CEO of a company, it's like almost not there half the time.
Really? It's wrong.
It's wrong.
Or not there.
It's wrong.
So Chris Caton from Prologis was just quoted saying that they've got 5,000 assets out of the 50,000 in North America. I think don't quote me on that. I think that was kind of roughly what he was saying. But that 5,000 wasn't enough data. They actually want the data on the other 45,000. These models, because traditional economics was compensating for not having enough data.
Yep.
Do these models have to compensate for having too much data?
I think it's...
Or cut through the noise, at least?
Yeah, I think it depends on how hard the problem is you're trying to tackle, right? And what I'd say is, in general, there's way too much data. Look, my favorite quote is, so there's this concern in generative AI right now, that the generative AI models are going to pollute the internet with all this generative AI content, and then when we go to train the next round, if you've seen a Star Trek episode where there's copies of copies of copies of copies and everything gets a little haywire, right? Like that's what's going to happen. Like people are concerned about that, okay? And you know, what's interesting about that idea is that these models are reading that we're all concerned about that right now, right? And when they're trained on this information, they're going to be aware that this is a problem, right? This idea around the data. So to come back to, you know, the question of is it too much or not enough, or you know, I think it's really a question of like, what are you trying to predict? How hard of a question is that, right? Like if you're trying to predict whether or not you should invest in like a heating project in a real estate like asset of some kind, that's actually not that hard of a problem. And you might need a sample of 10 to 20% of all available real estate assets, right? If you're trying to predict like supply and demand and like clearance rates of rents in multifamily homes in a certain, you are going to be in a place where you're going to need more of a system dynamic map. You need a pretty significant set of data. Right. And by the way, you don't just need data about the assets. You need data about the market that surrounds it, the context.
All of those variables.
All of it, yeah, because that all, employment.
Can we talk a little bit about, because companies now are recognizing the need to build their own private LLMs versus, by the way, don't dump all your confidential information into any of the platforms because that's all wide open to the public. I don't know that people realized that originally, but can you talk about how companies will shield themselves by having these private large language models and how they can safely bring data in from the outside without suddenly blowing a hole in their security?
Yeah, actually, if we can bring back up the slides, I want to just show you.
You probably have a slide.
Yeah, this is
I interrupted.
What's going on right now in this space. So private LLMs, or what you call them open sourced LLMs, right? They're basically a thing you can grab the code and then you can have your own people train it and make it do what you want, not really have to give the data to someone like Google or Facebook or OpenAI or any of those kinds of things. They're exploiting.
Right, because they'll use my data to train their tools. I don't really want to do that.
They will as a consumer, absolutely. Right. Remember we talked about piercing the shroud of meaning? Yeah. If I asked like a question like, hey, what's your social security number? Has no idea, it'll make something up. If you load a piece of paper in with social security number, remember we talked about it'll look at the kind of thing on the wall, the shadow on the wall? Well, the shadow on the wall is your social security number, and it will memorize that, and it will pin that question the next time someone asks. Forever. Okay. Or at least until they retrain, not forever, but until they retrain.
Okay, but it's...
Yeah, as long as that's in the data set.
The internet is forever.
Yeah, it's pretty forever. We'll see what happens with some of the media lawsuits and some of these things, right? They get things sucked out. But what you see on the right is actually the number of models that are on this thing called Hugging Face, which is a very funny imagery if you'd like to picture what a hugging face looks like. But these are where most of the open source models are and kind of the cool kids on AI right now. It's exploding. I mean, look at that growth right there. That is like the picture of an actual exponential curve almost, if you look on the right. And when you go a little further, it's not just that the model's exploding. What you see on the left are actually the number of parameters in each of those models. What's the average number of parameters are growing? And you can see it started off at like 100, I think it is. I can't even read. Yeah, 100. And it's now up to, 706. there's massive growth in the complexity of these models, not just in the number of models. And you put these two kind of exponential things together and you get a tidal wave, right, in this space. The reason people want to do it is, like just what you said, you don't have to give your data away, but there are some really new innovations. For instance, OpenAI has launched GPT Enterprise, and they've launched OpenAI Enterprise, and in that, there's 0-day storage of your data. They will not train the model on it, right? It's your own environment. It's basically like you're on your own instance of AWS or Azure, where your data is secure behind there.
So if I've got a portfolio of 100 assets, and each of those assets has 100 leases, I can now feel comfortable analyzing that stack of leases, learning from that without any concern about what's going on in the outside world.
If you're on something like GPT Enterprise or Microsoft's version, there's a few versions that absolutely, there's no doubt. And one last thing around cost efficiency is, I won't say who, but one of the big financial players spent roughly $10 million, there was a news article about this, custom training GPT 3.5 on their data. They got done, GPT-4 came out that same year, and it was better without being custom trained on doing what they wanted to do with all their data. Just think about
So just to clarify, they had version 3, they spent a ton of money to get version 3 to do what they wanted. When version 4 came out, they could have just pressed a button and it would have.
Yeah, and they thought they needed to give it all their secret data. But the reality is, we've done some really interesting things with these models where you wouldn't think that these models, for instance, could value options and derivatives. Mm-hmm. We've loaded our debt portfolio into these tools we have a very privileged, one of 5, what's called a founding partner or founding customer with OpenAI and ChatGPT Enterprise. We work with all of them, but what's interesting about that is we loaded this in, as part of this test, and then we loaded in all of our swaps and hedges and collars and all that kind of thing, and then we just started saying, what's the refinancing risk if interest rates do this, blah, blah, blah. And then we were like, well, maybe these aren't the right questions. What should the analysis look like? And the thing came back with a 15-step plan that was better than the best analyst at the best investment bank.
Wait, so you asked it to design its own questions?
We asked it, and then I just say, great, let's run number 4, 5, 6, 9. And it ran them all, and you know what 9 was? It was a Monte Carlo that did 10,000 interest rate scenarios, and it asked me all these questions. Do you want it to revert to mean? Do you want it to use Bayesian inference? All these kinds of things. I didn't understand what all that was, so I just asked it, what does that mean? And I had a multi-hour conversation, and by the end, I had run a complete stress test of the entire portfolio. And you ask yourself, how could it do this, right? And this is the question, sort of. I was working on GPT-4. How could it do this? The reason is it's read almost every finance book in the public domain. Right. It's read Black's diary and Scholl's diary, and it understands why they're important, right? And those kinds of things. And it can run these calculations. Even now, they're starting to do increasingly sophisticated math that's going to be replicable quite soon. So.
Okay, I'll say it again. It's a little scary.
It is.
It is. That begs another question about. Anyway, go on to the next slide because I want to stitch some of this together and then start asking questions related to real estate.
Yeah, well, I think I thought I'd put a real estate thing in. If you want to just boil it all down, what's happening this year, I call this the sea level versus the skyscrapers, okay? What is the sea level? The sea level in this analogy is all of the broad platforms like ChatGPT, right? Or GPT-4, or you've heard of Llama, or you've heard of Gemini, or fill in your favorite cool little short Silicon Valley name. But there's 5 to 10 companies, Anthropic, that are dumping water right now into the ocean, and they are trying to get this capability to be able to basically be like, what if you had taken a new person in the world and sent them to graduate school, and then they graduate, and then you can ask them, okay, I'm going to give you some training, and I'd like you to be able to do this new job for me. Maybe it's value a real estate asset. Maybe it's figure out if there should be a capital project, whatever that thing is. They're trying to make these things have 2 things. The first is superhuman performance. That's a very simple idea. Take all our IQs, add it together, it's still smarter and better at the vast majority of tasks. That is quite likely to be seen, I think even potentially this year, in many tasks, okay? To just juxtapose that, currently On some tests, it's about 80% as good, and on some tests, it's 99% as good as human, and some of them, it's a little lower. But like, really pause and think about that for a moment. Everyone should just look around at the 10 people around you. It's better than 8 of them at most things. Okay? Not everything, but most things. And so when you think about superhuman, there's going to be very few things that humans outperform. They're going to tend to be highly ambiguous, leap tasks, theory of mind, those kinds of ideas. That's the sea level. And what's happening is that sea level is rapidly rising, right? And even to the extent that 3.5 being custom trained got put out of business by 4 the next day, that kind of thing. What are the skyscrapers? The skyscrapers are businesses, software businesses, and AI businesses that are meant to help a very specific problem or help an industry. Good example. One of the biggest areas of innovation right now that is happening is actually in law and in finance and in customer service, where people are deploying very highly tuned versions of these models to read contracts and pull out meaning from those in a way that used to take a lot of time, right, in a law firm. Maybe outside counsel will help you with that. Same thing on coding, right, software development. There was a version released, I think it was 2 weeks ago, called Devon. You've heard of Copilot, where it's your Copilot. What if you're its Copilot? Because that's the model, right? Where every software developer has 200 AI software developers working for them, and they become sort of this master conductor that's working on it. So these skyscrapers are rapidly sort of growing in capability, and they're trying to stay ahead of the water level, because GPT-4, when it released and they put out these things called GPTs, it wiped out hundreds of companies that were built to kind of just store, prop up some of the missing capabilities of these things.
But they were built on 1, 2, and 3, and now suddenly they're gone.
Yeah, they were built on 3.5, and they were trying to maybe help with all these little things it couldn't do very well. Like, it didn't read PDFs very well, for instance. And so there were companies that were like, hey, we can help it read PDFs and be able to analyze those.
How do you, as Carlyle or any company here in the room, how do you future-proof? How in the heck do you stay ahead of it if you're going to make a commitment and then 3 months later, everything you did has been replaced?
I think there's a real question around investment levels. Like, if you're doing multi-million-dollar AI projects, you better be really sure that something coming is not going to.
And there was an article in the journal just a couple of days about this. I took some notes on it, but it was discussing this issue that the early adopters, rather than the fast followers, were spending a ton of money. And to your point, version 4 comes out and everything you spent on version 3 is gone.
Yeah, you're getting stranded capital investment in AI right now from like 2 years ago.
Yeah. Can you clarify something for me? So these are large language models. I know they can write code, which goes to your point where you asked it to write ask its own questions, which is really fascinating. How about from the finance standpoint? So we're used to using AI to do complex financial, and you too at Carlyle, complex financial analysis. How do large language models kind of enable a new level of financial analysis?
You know what I love about what I do is that you can just see it right now. So if you want to, take your phone out and go to ChatGPT and ask it if it can build a valuation model for fill-in-the-blank real estate asset. Yeah.
Yes.
And it can. That's exactly right. And if you want to, you could just go through okay, what do you need from me? What kind of data do you need from me? And it will start asking you the questions. And by the end of it, you'll have this model. And then you'll say, can we do some scenarios? And it'll say, great, here's 10 scenarios that you could think about running. The answer is that these models, and I want to talk about the deficiencies in just a moment.
Because it's not quite crunching numbers.
Well,
is it crunching numbers yet?
It's like, it's this. There's a language of math right now. It's called Python.
Yeah.
It's the hot language, right? In math and coding and all these kinds of things. And these translate from English to Python. They're like the world's greatest translator. So they're building Python code, and that Python code will grab all your data and do math on it, and it will hand it back to the language thing, which will talk to you about it.
Okay. So that's kind of the interface.
That's the interface for now.
Keep in mind that this is an industry that runs on a 42-year-old technology called the spreadsheet.
Yes, yes. I think this is the first time that we're seeing potentially a threat to the spreadsheet.
Wow.
I think the spreadsheet and Google are what all business run on, quite frankly, and like almost all software is trying to replace it and does a bad job.
And it's a beautiful piece of
Beautiful.
engineering.
Oh
It's
my
a
God.
beautiful solution and has
Yeah.
served us well for 42 years.
Oh, yeah, and it still will be around because it might be the window that humans are comfortable looking at to engage with the model, but you can build, your capital valuation models inside of these things and then just say, I need to extract step by step, and it'll put a little link at the bottom and you click it and it drops a CSV file out where you can just take a look at what it's been doing at every single individual step and pull it out. So, the thing people are excited about, there's been some big breakthroughs in chips. There's been some big breakthroughs in matrix math. I don't know if you've seen, this is the kind of math that you have to do to make these LLMs and also render video games, which has been great for NVIDIA, no doubt. But that matrix math breakthrough and some of the algorithms and a few other things are basically causing, I think we're sitting, months away from LLMs that are math. So you call them MMMs, massive math models. Right? MMMs, massive math models. And they're going to be able to work just side by side with each other so that the way you engage with the massive math model isn't math. You engage with it through conversation, and it's able to communicate right back to you. And I think the last thing is you've heard of hallucinations.
Yeah.
You've heard of inaccuracies, right? These kinds of ideas. The rate of those is falling dramatically inside of the models. We were just at OpenAI last week talking to them about this. And you can sort of see the hallucination rate is falling. Right. And there's a very simple solution right now that you can use, because I think the ones that are coming out this year and next are going to largely stamp out this is it perfect thing. It's going to tell you where it got its information. It's going to tell you if it's not sure, for instance, those kinds of things. But the real innovation you can use right now is you could just run a model, kind of like NASA did when they sent the spaceships up to the Apollo missions. They were worried that the gamma rays would hit the transistors and cause a miscalculation, and we'd end up on Mars instead of in the moon. Right. So they sent up 5 computers, and they made sure they all said the same answer all the time. Right? And what you can do is look for alignment across running 3 or 4 models that ask all the same questions. Right. Like, what's the refinancing risk of this piece of debt, And now it's fast to be able to do this. So belt suspenders and duct tape, but you can now do that because it's so quick and easy. It's not inexpensive, but it's quick and easy. And it's not, just to build one quick thought on it, it's not just that it's easy, it's worth doing that in some cases. I'll give you an example. That data analysis takes 2 people in our company 14 days to do, and we did it after we got the data lined up in about 30 minutes. This is not like 30% gains, right? Yeah. We have some of our portfolio companies that process claims and some of these kinds of things. There's this process of reading a claim and summarizing it. It's gone from 10 to 12 minutes to 2 seconds. Wow. We have time for questions, and I'm sure there are a bunch of questions. Wait for the microphone so that everybody can hear, and then if you don't, I have 2 pages of questions that we haven't gotten to yet. But we have a question down here. Can I get a quick microphone? I'll repeat it if you... Or we'll repeat it. Just yell it out for us.
Why do we need allocators, investment managers? If this is true, why do we need allocators and investment managers? And how do you sustain any kind of alpha?
Right. So is it possible that investment managers will become obsolete?
Well, you're saying they are already. If you can actually get to a correct answer through AI, your model is not going to be sustainably better than Blackstone's or TPG's or KKR's. And you're all going to be behind the tech companies. So how do you create alpha? Even your data sets are ultimately not really proprietary.
Yeah, I think we're in I would definitely take issue with the proprietary nature, and we can come back to that some other time. But
it's just a function of who's got the biggest data sets.
It's a function of who has the biggest data sets. That's exactly right. It's also a function of, actually training AI models is a business process. Like, you can have all the data in the world and just be terrible at training an LLM. And it isn't easy to learn, because how many people know to do that? I mean, there was an article today that says, the 100 people that you need are going to cost you $1 million each to train an LLM. Right. And those are like hands on keyboard, not managers. Those are hand on keyboard kind of folks.
And they're offering them $1 million.
Yeah, they're offering
aren't they going to train them? It's going to train itself, though, right?
I absolutely think it'll train itself. But when you come back to this question, you look at why is OpenAI so good, right? The answer to the question is they've built a business process, and they have a way of doing this that is highly differentiated. In fact, if you talk to Ilya, who kind of did some interesting things related to leadership, obviously, back in November, he'll tell you we don't need any more data. all we need to do is get more meaning out of the data that we have. So the question on why do we need asset managers? The answer is, right now, there's a lot of ambiguity in the world. Data is not the only thing, right? There's things on the people that you're dealing with, and can you trust them, and some of these kinds of elements. And certainly some of that you get some support from AI around, like, someone trustworthy, background check, some of these kinds of things. But when it comes down to it, I think really the next decade is going to be about the handshake. Whoever is using technology the best are going to be the winners that are creating alpha. And the way I say it is this: AI is not coming for your job.
Right.
It's the person who passionately loves AI and wants to use it to do your job better than you. They're coming for your job.
Some recent research from MIT Sloan that took a look at, they gave AI tools to different people in companies. And the results showed that the high performers did have a measurable increase in their performance and productivity. But it was the mid to lower performers that actually had a greater percentage of improvement. And so what it did was pretty much raise all the boats.
Yep.
Now that may be a short-term experience. I don't know what the long-term looks like. But it does lead to a question: what should my kids be studying right now? Because we have students at MIT that they may come out in a year and be behind. And,
yeah.
and we're kind of at the leading edge usually. So what can you say about that?
Yeah, I think, so let me tell you a story about my son. He's 16, and he and I were having a discussion, and he was the one who really got into these GPTs and drugged me into them. I was doing traditional AI, and he's just like, "Dad, this thing is really much better than you think. You got to keep trying it." I'm sure many of you had this experience where your kids woke you up to something in the world. And I had known about the transformers and used a few. We actually did some experimentation with GPT-1, and he said, I could see, I'm going to be concerned about some of the rising temperature in the world, and this little columbine flower. I live in Colorado, the columbine flower, and I wanted to grow and thrive. And so what I can do is, it's very soon we're going to just sequence all the DNA of all the organic life. And we're going to give that to GPT, and it's going to know everything about the life itself, and it's going to know the genetic code. And I can do something like this. I can just say, can you give me 5 things that look like the columbine that have 2 degrees more heat resistance that we could think about splicing the DNA into the columbine? And then I looked at him and said, you don't know anything about genetic testing or DNA, because I'm not a good dad. And he said, yeah, I just killed the creativity. And he said, that's okay, Dad. I'll just ask it to explain. I'll just put the pictures up and just keep asking it questions until I do understand it, and then I can select the samples that I want to try, and I can use CRISPR to insert the DNA into the columbine. And I said, you don't, just in case I wasn't a good enough father in the first, I said, you don't know how to use CRISPR and wouldn't know how to read the results of your test either. And he just kind of looks at me and he says, Dad, don't you think there's all these people right now just working on robots that use generative AI that you can just kind of tell them what you want them to do and they can run experiments for you and interpret the results? And I said, that's a great point. So I go and I look, and there's things called Pick GPT, Catacomb. If you want to look, there's chemistry robots that are doing experimentation right now, and the versions that are coming are going to really enable this robotics revolution. Because the problem with robotics right now is, a robot is traveling down. Who has used any form of an LLM or GPT or anything? Can you raise your hand if you've asked any question? Okay, great. So you've seen the great waiting game, right? Like you put it in and it's like, okay, I don't know what's going to happen, but I'll check back in 20, 30 seconds. You can't have that when a robot is moving down something and it needs to turn left instead of go straight, right?
Not a good idea.
And so they're going to be much faster, and he's absolutely right. That's happening. So what does it mean? If you think about sort of on the left, reading, writing, communication, these kinds of things, those are things all humans can do. If you think about things like genetic engineering, you need to have a PhD to do that kind of activity, right? And I think what's happening is this is breaking down the barrier between idea and execution. That's the thing. And so, I tell my kids that I want them to be curious and I want them to be able to communicate well and use language, because language is how it's the greatest innovation that we've ever had, right? And I think that these models, you know, are going to reward people who are producing value in the world, because if we're going to go very rapidly, I think the question around investing is very interesting, right? I think we're going to see, you know, we'll need investors in these models for a long time. Not while I'm working will they completely displace, and we'll move to like quant trading, which we've seen in public markets. But I do think that, you know, we're approximating that future right now. And when you think about what's really going on, we're going from words to bytes right now.
Right.
We're going to go from bytes to atoms, and that's a really interesting situation. Certainly interesting if you're in real estate, because you know, buildings, property, those are atoms, right? And you know, I think if you have kids, you want them to really value communication. You want them to, you know, feed their curiosity, feed stock. Don't just like force them to do this thing that's going to be the it job. Like if you're forcing your kid to be a Python developer right now, why?
Yeah.
These things write Python better than like 90% of Python developers write it.
Wow. Other questions? Raise your hand, we'll get a mic over to you. We have somebody back here. Question in the back?
What's your view on the competition between Gemini and OpenAI, and who wins out, or is there one winner?
Yeah, I think the challenge for Google, and it's not just Google, is they have a franchise to protect, and OpenAI doesn't care, right, about the franchise. You know, they're not trying to they're just trying to innovate and help, you know, people get things done and do them differently. And so when you look at Gemini, you know, Google is sort of in a spot where they're darned if they do and darned if they don't, right? If they release the thing and it, you know, is not sensitive enough to things like race and some of these things that you get criticized for, that isn't great. If they do it and it's, you know, misconstruing history, that isn't great. So what are they going to do? I think they have a real challenge. They've got massive, large quantities of data, and I don't think that they have a very good business process to turn that into large language models. So you look at it, they kind of rapidly came out with Bard. They rapidly came out with Gemini and had to walk that back. Gemini is pretty good. You know, like, OpenAI has been working on the next 2 versions for a very long time. Think about how long ChatGPT or GPT-4 came out. It was quite a while ago. And so I personally think that they have a much better business process, a much more agile mind. Got some really great math people, obviously, working
But we'll probably have multiple tools, multiple platforms,
We will.
maybe for different industries.
We will.
You did go to the big powwow on the West Coast, right?
Yeah. We were at OpenAI headquarters with 65 of our you know, CEOs, COOs, CTOs. Harvey, our CEO, was there, and I was there, and we had some really interesting meetings where we saw some things about the roadmap. A lot of this stuff I can't talk about it, but I can.
Yeah,
just
you probably
say,
signed non-disclosures.
Yeah, absolutely. And we would never engender or endanger, the partnership.
Yeah.
But it was, you know, I mean, it's really
anything kind of generally that you can share that's just exciting or struck you as amazing or.
Well, I will say, in answer to that question, there's no doubt in my mind that right now OpenAI is vastly superior to the other solutions. Anthropic has done some really interesting things. There's some really neat stuff you can do in Hugging Face. Like, you can find reason. We do stuff with other large language models too, but if you're looking for like a cleanup hitter that can just, you know, take care of most tasks pretty well, and if you kind of train it and give it some good prompts, it can do even better. I think, you know, they're going to really be hard to catch. Yeah. Be really hard to catch. And the thing that we haven't talked about is what happens when we unleash these things on themselves. That's really the question. Oh, I have a cute picture on my screen. I'll put it up since it's there.
Yeah, and I didn't really want to end with this one because it can be a bit of a downer. So we'll talk about that in a moment. Let me take one more question.
Yeah, go ahead.
Any more questions out there in the audience? Because this is such a rich topic with a lot more questions than answers. So we'll do one more question, and then we'll just come back. But, you know, leave us on an optimistic note.
Oh,
I'm sure you will.
I'm very positive on it.
I'm sure you will.
Yeah. Hello.
Yeah, so do you think every brand of technology requires like a catchy term, like as robotics had AI, renewable energy had clean tech, you know, payments, banking had fintech. Do you think every brand of technology needs a catchy term to actually be related to the public?
I think in some ways that's the power of language, and that's why these models are so amazing. They cause adoption. So I do think that the catchy terms, they really matter, right? And you're just seeing that, Claude, that sounds cool, Gemini,
There's a little bit of branding in
there.
right?
There's just kind of that little branding, trying to get people, I think, to be excited about their models and also personify them a little bit. You see that a lot, but definitely true.
So tell us what scares you at this point? And then I have a follow-on question.
Yeah, well,
what concerns you? Maybe not scares you, but what concerns you?
I'm not worried about the singularity. Let's start with that. I haven't given that a lot of thought. I think there's a difference between AGI, which is artificial general intelligence, meaning you can throw these models at something they were never trained to do, and they can figure out how to do them, and sentience, which is awareness of one's own existence, right? That idea. But I think the thing that I've been most concerned on is what happens in a post-truth world. And I think that the ability to generate content and assets and collateral and all these kinds of things that aren't necessarily true and fit agendas and that type of stuff, and they're very compelling to the human mind, is really tricky, and it's being coupled with a very difficult time in the media industry, which has typically been I think a very important interstitial fabric in society to help us make sure that we're really looking for the truth and those kinds of things. And I think like when you unwind our ability to talk to each other and trust each other, right? If communication was the first invention, trust was the second. And I think the kind of ability of these models to kind of disrupt those human norms is that's what I'm most concerned about. But I think like there are solutions. So to optimism, when you shoot a photo or you make a video or you give a speech, there are things that can do chain of custody, right? Yeah. And it's a much better use of maybe some of this than like cryptocurrency, for instance, right? For blockchain. And so I really believe things like digital chains are gonna become imperative so that we know things are real and that they're not false. But that's what I'm most worried about.
So give us a vision, look way out. What this is already like magic, but what's it really going to be like? Yeah. Assuming we solve the concerns, and how will this change our lives?
Yeah, well, I think the best analogy is when we discovered electricity. Wow. That's on the level you need to be thinking about this. And I say that because like electricity was used in smelting factories and other places to make different kinds of turbines, which allowed us to go from
the follow-on effects
coal to
completely
CCGTs.
Changed the world.
Yeah, totally different kinds of technologies. But it's used on itself, right? Electricity is used on itself to make more and better electricity. That's kind of the big idea. And then it fundamentally drove a massive transformation of the economy. And I think you're looking at something. Maybe you had the Industrial Revolution, I think you have the cognitive revolution, or the AI revolution coming in, and what's going to really propel this are kind of three things, right? The first one is more energy and more chips, right? That's kind of number one and two. And I think that the third thing that's really going to propel this is when we start taking these bots and we allow them to start working and improving on themselves in ways that humans can't fully comprehend, and it breaks you off of the curve. When you stop and you think about Moore's Law, we are off Moore's Law right now, already in this. You look at the number of models, you look at the impact. Very rarely is a technology released, and in the same year that it's released, you can point to some substantial business cases that reduce costs. I'll give you an example. The Klarna CEO talked about this. It was 3 or 4 weeks ago, but they got rid of 700 customer service people and added $40 million of EBITDA because of a pilot they did with OpenAI that took them 6 months to do and 6 months to make sure that it worked out. Call resolution times for customers fell from 11 minutes to 2. That is in hype cycle.
I don't think we've experienced the business case being so close to the release of the technology.
Yeah.
This is what we've observed to be different from the others.
Yeah.
So pretty amazing. Thanks for your optimism. Thanks, Matt, for sharing all of this with us. And let's thank Matt for being with us.